Python's magic methods also give you complete control over how an object's attributes are accessed. Your class can define methods that intercept the process anytime an attribute is set or retrieved. So let's open up the magic_adder_start file and we'll see how this works. So here in my code, I have the book class, which defines some attributes and also overrides the stir function that we saw earlier in the chapter to print out a nice version of the object. So let's start off by seeing how we can control access when an attribute's value is retrieved. So Python lets us define a magic method called getAttribute, which is called whenever the value of an attribute is accessed. So what I'm going to do is override this function. I want getAttribute, and that is going to be passed my object and the name of the attribute. So this gives us the opportunity to perform any operations on the value before it gets returned. So for example, you can see that we have an internal attribute named discount. So let's imagine that we wanted to automatically apply the discount whenever the price attribute is retrieved. So first, we can check to see if the name argument is equal to price. So we know that that's the price attribute being accessed. And now here's where things get tricky. So since we're already inside the function that's going to get called whenever an attribute value gets accessed, we can't just refer to this object's attributes by name, because then this function will just get recursively called over and over again, and it will eventually crash. So what we need to do is get the value of the current price by calling the superclass version of getAttribute. So I'm going to write p equals, and then I'm going to call the superclass's getAttribute, and I'll ask for the price, and then I'll do the same thing for the discount, and I'll name that D, and we'll put in _discount, and then I'll just calculate the discount. So I'll return P minus P times D. And if we're not operating on the price attribute, we'll just go ahead and call the superclasses getAttribute, so everything just works normally. So I'll just call getAttribute with the name. All right, so let's scroll down, and you can see I've got some code that creates a couple of book objects. Let's go ahead and try setting the price of book 1 to $38.95. And then let's go ahead and print B1. And remember, the print statement will trigger the stir output. So I'll run this. And we can see in the output that the price of the book is reduced by 10%, but clearly the other attributes, the title and the author, are unaffected. So we can also control the setting of an attribute by overriding the setAttr function. So let's try that next. So here I'm going to override setAttr, and that takes a reference to my object, the name of the attribute, and the new value. So in this case, let's use setAttr to enforce that when the price attribute is set, the caller is using a floating point number. So once again, we'll check to see if name is equal to price. And if it is, we'll check to see if the type of the value that we were passed is not float. Then we're going to raise an error. And we'll just say the price attr must be a float. Okay, so now we're going to raise an error if the value that we were passed is not a floating point number. So if we pass that test, then we'll just call the superclass's version of setAttr. So we'll just go ahead and return. And once again, we'll call the superclass, and we'll pass in the name and the value. All right, so once again, let's try this out. I will comment out my previous example, and I'll set the price of book 2 to be 40 as an integer, so that should cause an error. And then we'll print B2. So I'm going to save, and I'm going to run this. And when I run it, you can see that I'm getting my error right here. It says the price attr must be a float. So let's go back to the code. Now I can either fix this by making this a floating point number, or I can cast it to a floating point number by using the float function. All right, let's save and run it again. And now you can see it works fine, right? So I set it to be 40, and then 10% off of 40 is 36. All right, let's do one more example. Let's go back to the code. There's another magic method that lets us customize the retrieval of attributes, but it only gets called if the given attribute doesn't exist. So it's the getAttr version of getAttribute. So let's go ahead and give that a try. So I'll define that method. And that's going to take self and name. All right, so this version of the function only gets called if the getAttribute version either doesn't exist, or if it throws an exception, or if the attribute doesn't actually exist. So let's go ahead and comment out my overriding of getAttribute. And then let's implement this version. So all we're going to do is return the name, and we're going to say is not here. All right, and then let's try to access an attribute that we know doesn't exist. So I'll comment this out, and I'll just try to print out, b1 dot, and I'll call it random prop. All right, so let's go ahead and run this. And you can see that now I'm getting the output random prop is not here. Now, you could use this to generate attributes on the fly, or if you wanted to extend the syntax for accessing attributes. But, just like other methods, you need to be careful that you don't enter into a recursive loop. But by using these attribute methods, Python gives you a great amount of flexibility and control over how attributes are retrieved and set in your classes.